This lesson is on similar polygons. Polygons are considered similar when they have the exact same shape, but one is either an enlargement or reduction of the other. Keep in mind what the different parts of a polygon control. The angles are what control the shape of the polygon, and the sides are what control the size of the polygon. Similar polygons have the following characteristics. They have congruent angles, which hold the shape together, and proportional sides, which means the size of it is different according to a scale factor. In the diagram below here, you have quadrilaterals ABCD, which is similar to quadrilateral EFGH. The symbol tilde is used to indicate similarity. So ABCD is similar to EFGH. As you can see below, angle A and angle E are congruent, angle B and F are congruent, angle C and G are congruent, angle D and H are also congruent. So that tells us that the shapes have to be the same as each other. Then down here below is what we have, what we call a statement of proportionality. We can see that AB over EF, that would be this side over this side, is the equivalent to BC over FG, this side over this side, and CD over GH, and then finally DA over HE. Because each of those, when you set up the corresponding sides as a ratio and reduce them, if they are properly similar, they will all reduce down to the exact same ratio, which is what is required for similar polygons. So writing our similarity statements here, if we got these two pentagons below, JKLMN and pentagon STUVW, which are created so that they are similar. We need to list all of the congruent angles and then write the ratios of the corresponding sides in a statement of proportionality. So our corresponding angles here would be angle J and angle S would correspond together. Angle K and T would correspond to each other. Angle L and U correspond. Angle M and V both correspond together. And angle N and W correspond together. Our statement of proportionality would be JK over ST, that's these two top lines. KL over TU, KL over TU, we're just working our way clockwise around our objects. LM over UV, MN over WV, and NJ over WS. Notice all of the segments that are in the numerator of our fractions all come from the left pentagon. All the ones on the denominator all come from the right pentagon. Now, if I were to start off where I flipped them, where ST was on top and JK was on the bottom, we would have had to do the reciprocal of every one of these. Once we pick a direction to go, we need to stick with it throughout the entire statement of proportionality. In this example, we're going to use the information given to list all pairs of congruent angles and write the statement of proportionality for this figure, just based off of the similarity statement. So the similarity statement we have here is triangle DEF is similar to triangle PQR. Just by looking at this, we can tell that angle D has to be congruent to angle P because those are first in line. Our second in line, or our middle letters, would be angle E and angle Q have to be congruent to each other. And then finally, angle F and angle R also have to be congruent to each other. That shows us that all three angles of each triangle are congruent, meaning that they're the exact same shape. Now to show our statement of proportionality, we would take our first segment here, which would be DE, and we would put that over PQ. So we got DE over PQ. Our next one, we got EF. EF is our second and third position over QR, which is our second and third position over on our other triangle. And then to finish it off, we have DF and PR to finish our statement of proportionality. In this example, we want to decide whether the figures are similar or not. If they are similar, at the end we need to write a similarity statement. So to check for similarity, first thing we would do, the easiest thing to do, is take a look at your angles. Do you have enough information to say that all the angles, all the corresponding angles are congruent? As we look here, W and P are the same, X and Q are the same, Y and R are the same, and angles Z and S are both the same. So we do have two objects that have the exact same angles to them. Now what we have to do is we have to check to make sure that we have all the corresponding sides being proportional to each other. So to start with that, what we're going to do is we're going to look at WX over PQ. WX here is 15, PQ is 10. That gives us 15 over 10, which reduces down to 3 over 2. Now it's time to check our next sides. So we're going to go XY over QR. XY is 6, QR is 4. If we reduce that, that also reduces down to 3 over 2. As soon as you have a set of proportions that are not equal, you're done. You do not have to go any further. But because these are the same, we have to continue on. YZ over RS, YZ is 9, RS is 6, 9 over 6 also reduces to 3 over 2. And then finally, ZW over SP, that would be 12 over 8, which also reduces to 3 over 2. So we have all four angles that are congruent with their corresponding angles, and all of our corresponding sides, when we write them out as a ratio, are proportional with each other. So these two quadrilaterals are similar to each other. So we would go ahead and write ourselves a similarity statement. Notice as we write the similarity statement, it is very similar to how we write our congruent statement. Angle W is the same as angle P. Angle X is the same as angle Q. Angle X is second, Q is second. Angle Y corresponds with angle R. Angle Z corresponds with angle S. So we have to make sure all the corresponding parts are visible within our similarity statement. In these examples, we're going to decide whether the objects are similar or not. So as we take a look here to decide whether these two objects are similar, first we would take a look at our angles. We can see here we got 4 right angles over here, but we only have 1 right angle on our right side. So there is a possibility that we could have all 4 that are the same. So we have to check and see, is there any other reason that we could come up with that could tell us that these other angles in EFGH are also right angles? And there is. The fact that you have lines that are parallel. EF is parallel to HG. That tells me that angle F and angle G have to be same side interior angles that add up to 180 degrees. So if this is a 90-degree angle and angle F and G add up to 180, that means angle G also has to be 90 degrees. Likewise, FG is parallel to EH, which means angle G and H are same side interiors, and angle F and E are same side interiors. So that what that ends up doing is it makes E, F, G, and H all 90-degree angles. So our 90-degree angles over here on an EFGH match up with the 90-degree angles over here in ABCD. Next, we have to check our proportions. Notice that 7 is the longer side and 3.5 is the shorter side. Over here, 4 is the longer side and 2 is the shorter side. So as we set up our proportion, you see here that the long sides go together and the short sides go together. The top 2 values both come from EFGH. The bottom values both come from ABCD. It is important that you stay consistent as you write your proportion. Now to check if it is proportional, you would take 4 divided by 7 and 2 divided by 3.5. You would see that those two values end up being this equivalent to each other. You could also check by cross multiplying. 7 times 2 is 14 and 4 times 3.5 is also 14. So we have proportional sides, we have equal angles. That is enough to say that we have um, two similar polygons, two similar quadrilaterals to be exact. Quadrilateral ABCD is similar to quadrilateral FGHE. The only thing you got to be careful of here is that AB is a long side and FG is a long side. BC is a short side, so is GE. You just want to make sure all your parts match up as you write your similarity statement. In our next one here, this one actually has a quick solution to this. The quick solution would be that angle Q on the one on the right is at 88 degrees. The 88 degrees is not equivalent to any one of the four 90-degree angles over here in QLMJ. Just because of that fact alone, you can easily say that they're not similar to each other and move on, because you have to have all four angles congruent to all four angles. Here, we're sitting pretty good with our angles. You got four right angles on the one on the left. You got four right angles on the one on the right. And as you look at this, you can tell that these are going to be squares. You have a rectangle because you got all four right angles, and you got adjacent sides that are both equivalent to each other. So you got a square here that's 4, a square here that is 5. Chances are all squares are going to be similar to each other. There is not one example of two squares that I can think of that would not be proportional to each other or similar to each other. So 4 over 5 obviously is equivalent to 4 over 5. Sides are proportional. 8 right angles are involved. ABCD is similar to EFGH. In actuality here, because all the sides are equivalent, the order of the letters really isn't going to matter too much on this. The only thing you can't do is go ABD. You can't cut diagonally across. You either got to go clockwise or counterclockwise. This is a pretty easy one to put together. To decide whether these two quadrilaterals are similar, we could take a look here. The reason we put the 4 with the 3 and the 6 with the 4 is our 6 is our larger side on the left. The 4 is a larger side on the right. So that gives us the 6 and 4 together here. The 4 is our smaller side on the left, and the 3 is our smaller side on the right, which puts the 4 and the 3 together. 4 times 4 is 16. 6 times 3 is 18. 16 is not equivalent to 18, so the sides are not proportional. So, and there's no angles to monkey around with here. There's really no reason to think that these two rectangles are similar to each other. In this final one, we got two triangles that look like they could be similar. You got angle Y is congruent to angle A, angle X is congruent to angle C, angle Z is congruent to angle B. So right away you have angles that work out to be pretty well congruent to each other. Next up, we could take a look at our statement of proportionality. 4.5 is our smallest side on the in triangle ABC. 6.75 is our smallest side on XYZ. So those two would go together. 6 is our middle side length. 9 is our middle side length. Those two would go together. And 8 is our largest side. And 12 is our largest side. Those would go together. If you divide each of these fractions out, take a look at the decimals, you'll see that they are equivalent to each other, which means you got sides that are proportional and all the angles match up, so you got congruent angles, which is enough to tell us that these two triangles are similar to each other. So we would go ahead and name our similarity. We'd go triangle ABC is similar to YZX. Be careful on this. Make sure that everything matches up. Angle A is congruent to Y. Angle B is congruent to angle Z. And angle C is congruent to angle X. If two polygons are similar, then the ratio of the lengths of two corresponding sides in reduced form is what we would call a scale factor. You'll be asked to use scale factors quite often in these problems coming up, especially when you're trying to find the missing parts. So in here we're going to be specific. We want to find the scale factor from PQRS to JKLM. That is from the one on the right to the one on the left. So we so we're looking for a numeric value that's on corresponding sides. So here we got y and 16, no good because of the y. X and 10, no good because you got the x. 15 and 12, that's what we're looking for. Two corresponding side lengths that both have numeric values. The, the numeric value from PQRS is the 12. The numeric value from JKLM is the 15. So we're going to go 12 over 15. Reduced is 4/5. Now, there is nothing wrong with putting the small value on the top and the large value on the bottom as long as you stay consistent through the problem. Or if you want to flip-flop it, put the large one on the top, the small one on the bottom. That doesn't matter either as long as you stay consistent. Here, they want the scale factor in a specific order. They want JKLM on the top, which is this one on top, and PQRS, this one on the bottom. Oops, wrong way. Here we go. So JKLM on the top, that would be 15 on the top, 12 on the bottom, reduces to 5/4. We can use these scale factors to find the missing values. So we're going to find W first. So what I would do here is I would start with my scale factor. Notice I want small on top, large on the bottom, small on top, large on the bottom. The sides that correspond with the W is QP and KJ. So we would go W over 25, small over large. We can cross multiply this. 5W equals 100. Divide by 5 gives us a W value of 20. Same setup for X. It would be a completely separate problem. You're going to do 3 independent problems here. First one for W, second one for X. We would set that up the same way, starting off with the exact same scale factor, this time looking at where your X value is and what corresponds with it. Our smaller value would be the 10. Our larger value would be the X. We know this is the smaller value because these all come from the smaller object, which makes them all the smaller value in comparison to the KLMJ. So cross multiply this. 4 times x, 5 times 10. That'd be 4x equals 50. Divide that out and you get x equals 12.5. Our final problem would be to find the y. So we use our same scale factor. This time we're going to go 16 over y. Again, 16 is the smaller value for these corresponding sides because these are all the smaller values. The y is the larger value because it comes from the larger object. 16 over y is the same as 4 over 5. Cross multiply 5 times 16, 4 times y, that'd be 4y equals 80, and y gives you a value of 20. In this problem, we're going to do it's going to involve a little more algebra to it. So to start off this problem, we're looking at two similar polygons. They're triangles, and we want to find the values of x and y. To start off any one of these problems like this, what we first want to do is we want to try to find the scale factor. So to find the scale factor, we're going to set this up using the numeric values that correspond together. Here we got the 15, the 10. Those two sides correspond well together. So we're going to create our scale factor using those. So we go 10 over 15. That reduces down to 2 over 3. So 2/3 is our scale factor we're going to use. Now to find x, if we set up 2 over 3, that means we're going small over large. The x value is here. The corresponding side for the x would be here with the 6. So as we set that up, that would be 2 over 3 equals 6 over x minus 2. We cross multiply. 3 times 6 is 18. And then 2 times x minus 2. It is a critical step that when you do the 2 times x minus 2, that you put the x minus 2 in parentheses and then show your distributive property. 2 times x and the 2 times 2. You end up with 2x minus 4 equals 18. Add 4 to both sides. Divide by 2 and you have yourself an answer of 11. Now, separate problem would be to find the y. We're going to use the same scale factor of 2 over 3, but this time the y plus 3 corresponds with the 8. So it will be 2 over 3 equals 8 over y plus 3. Every value from here is considered the smaller value. Every value from this triangle is considered the larger value because the 15 is larger than the 10. Cross multiply this. 3 times 8 gives you the 24. And then 2 times y plus 3. Again, you want to set it up to see the distributive property. Go ahead and distribute. Minus your 6 from both sides. Divide by 2 and you got yourself a value of 6. Here we have a similar problem. We're going to start off by looking at our scale factor. So we notice here, here's a congruent angle, and here's a congruent angle. That helps us out to figure out what sides correspond together. Notice here our only side that has a numeric value is directly across from our congruent angle. So that means the 18 has to correspond with the angle that's across from the congruent angle here, or the side across from the congruent angle. So the side across this congruent angle is 21. So we're going to match up the 18 and the 21 to create our scale factor. 18 over 21 reduces down to 6 over 7. That's the scale factor we want to use. So now we're going to go 6 over 7, and that makes these the smaller values, these the larger values. We're going to find x first. So if I go 6 over 7, then I'm going to go x minus 6 over, now the x minus 6 looks like it's the longest side of this triangle, so the x minus 6 is going to have to correspond with the 39, because that looks like that's the longer side of that triangle. So 6 over 7 equals x minus 6 over 39. Do a little cross multiplying. Make sure you show your distributive property here. Go ahead and distribute. Add 42 to both sides. Divide by 7. You have your answer of 39. Now to find the y, we're going to go with 6 over 7 again, but now we're going to go y over 27. It has to be 27. That's the only one we haven't touched yet. So 6 over 7 equals y over 27. You got 7y equals 6 times 27, which is 162. Divide by 7. That gives you a nasty looking number like 23 and a seventh. It's a good thing they made that nice and clean for you guys. All right, but that's it.